So today we will be talking about interfaces. You guys I would say there is like about 0.4 like percent, no, not 0.4%, like 40% chance that like you've heard about interfaces if you are sort of new to Go. Let me share my screen. Yeah, and today we just still about 30 minutes of the time to walk ourselves through what interfaces are in Go. Okay, so as Dennis rightfully said, my name is Francis Osei Annin. Been doing this software thing for some time now, and been using Go for about 6 years now. So I hope I'm able to lead the discussion and help you understand what interfaces are and what they are not. Okay, so by the end of this presentation, my goal is that, or my wish is that you guys would be able to understand what an interface is and what it's not, and also compared to some other languages like C#, JavaScript, and what's not, the implementation, how it is like in Go. Also, what an empty empty interface is or are, type assertions, the built-in interfaces that if you are learning Go you might come across, and then also what a composite interface is. So yeah, let's just dive right into it. Okay, so if you guys, I don't know, but anyone here with like a Java background or something, you can just like give me thumbs up, or C#, that's C based language style, guys can just give me a thumbs up or something. Or I don't know, or you guys are all Python guys. Yeah, Ebenezer for sure. All right, sure, no problem. So in other languages like Java, there are interfaces, but the implementation is a bit different. Okay, but the concept still cuts across the same. An interface is not a concrete type. When we talk about a concrete type, you are thinking of creating a type or like an object out of a type. So you have something like a constructor or an initializer if you are using languages like Python, and what's not. So those are concrete types, right? I assume you understand what I'm saying. And that's not what an interface is, but it's still a type. It's still a contract that binds objects to a certain condition. Once the condition is satisfied, they are types in their own rightful sense. I would steal this opportunity to call them abstract types, though they are not abstract types in its actual sense. But yeah, they are abstract types. If it's not concrete, then it's abstract, right? They are abstract types. So the definition of an interface mostly would be something like collection of method signatures in Go, right? We'll see it in a bit. I hope you guys like this stack of plates, So what's an interface? Let's just take an example with this shape thing. I'll switch to my oh sorry, looks like I'm sharing one screen. Stop needs to present something else. Let me present my entire screen. Okay, cool. So we'll just walk through this and see how we can create an interface. Okay, but first of all, let's see how we can create a concrete type. So let's go with the geometry approach. Let's assume we want to create, or let's say we want to create a shape type, like a shape, 2D shape, rectangles, squares, whatever, like triangles, right? And a shape has some properties. A shape has dimensions, and also it has quantity based properties like area, perimeter, and whatnot. So we would implement them on the object itself, right? So we can just type by just using the type keyword, and let's create this thing called shape. Give it a struct and call this as a shape type. In other language you call it a shape class, but yeah, it's a shape type. Now a shape could have anything. Let's see, length for now. Let's just say length for now, right? And the length could be of of a certain type, let's say float 64, precision, double precision, floating points number. Then the shape also has methods, as I said, quantity-based methods. For now, let's just try and implement an area and a perimeter. Okay, so we bind this to this object using either a value or a pointer receiver. If you were here last week, Dennis did a good job like explaining what this is. I'll not go over that. Right, so this is an area. The area returns, the area method returns a float as well. Then what will be the implementation? Let's see. The implementation will be, yes, this is the area, length times length. Right, now let's implement the last quantity, which is perimeter. Perimeter. By the way, this is a pointer receiver. Again, if you are confused and you don't know what it is, try and get a video and go over it again or search it up online and understand the difference between a value receiver and a pointer receiver. Okay, so let's return this and say, I don't know, like we should just call this I think I should call this a quadrilateral. That would make sense. So like a quadrilateral. I hope I got it right. Yeah, so the type we are creating is a quadrilateral. So therefore let's create a quadrilateral out of this. Great. So if you want to get the perimeter, then it is 4 times of the length. The length there becomes s the length. Cool. So this is what we have. Now we've been able to define a type called quadrilateral, right? This is no, I don't like this example. Let me just call this as let me call this as a rectangle. It looks more like a rectangle, to be honest, because, or a square. No, this is a square. So this is how my day in the life looks like, just debating about what is right. So this is a square type, right? And we can create one for a rectangle, a circle, and what's not. Okay, now I think we should create one for a circle too. Okay, let's create one for a circle, and that will make the definition of an interface very simple. So we create the same thing, create one for a circle. Then a circle is defined by its radius, and it also has, let's call it an area, which will be giving us what's the area of a circle? Pi r square. For now, let's just say c times c. This is not the right formula, but let's, for the sake of this presentation, let's assume it's radius times radius. Now for the circumference, which is the perimeter, let's just use any formula as well. Let's return 2 times c, just this, right? We know these are not the right stuff again. So we have a circle type and we have a square type. Now all these fall under a certain class of geometry. Let's call them 2D or plane shapes or plane figures or whatever, right? So what we can do is we can actually create an interface out of these set of types, for which each time we want to call a shape where we want to be a bit flexible, we don't have to just call only square or circle, because in that case then we have to keep using square and circle, and we have like a set of verbose code, like our code become like a lot, right? So what we can do to save our soul would be, okay, so what I'll do is I should create a package probably for this, but no, I'll just cut this, then put this down here so that you guys get it. So we've defined the types. Now let's define the interface. All you need to do, again, remember, we learned that an interface is not a concrete type. This is a concrete type. A square is a concrete. What we've defined with this struct here, type struct, is a concrete type, right? We can create a constructor out of it and say new square and pass in the parameter length, then return the return square this way. Sorry, this is a pointer. Square this way. Awesome, great. yeah, we can create, this could be a constructor if you want, right? So this is how you would want to create an interface of these two like different shapes. So you come here, you type your interface, and let's call it, what should we call it? I think let's call it shape, yeah. Apologies for my bad naming. Then we create the interface, we use the interface keyword, right? So to define an interface, you need to define the area, like the set of methods for which these types implement, right? And in this case, they are area and perimeter. So you write area this way, and what the return value would be, the return type value, then also perimeter. Then this is what you have. What you are saying is that now you can define a square. Anywhere you see a square, you can change the type and make it a shape, and it will work, or vice versa, because then a square now implements this contract. It does implement this contract. And yeah, I'm sorry, who's calling me? Sorry. Yeah, so it implements this contract, and it's almost as if it's the same type, but it's not. It's an abstract type. You can't create a new object out of shape like this. You can't come and say that, oh, you want to create, like, let's see, the way you create a circle or a square. Let's do it. So let's create a new square and call it, let's say, square one. Right, from the constructor, let's just give it square one and pass a length of let's say 10 something units. Now let's create circle one and pass another okay, I think we don't have a constructor for, so we can just define that now, and pass in the radius, return the circle. Yes, so we have this. So now we can pass in a new circle this way and pass the radius. The radius could be, let's say, 20. Okay, right. Right. So now we are having these warnings because we've not used them. You can't declare an object or a variable in Go without using it. No, you have to use it, right? Now, these two, you've declared them, and what's not. Actually, what you can do is you can come again and say, let's create a shape, like a variable called shape, and it should be of the interface type. This one here. This is an interface type. But mind you, this interface type is not a concrete type like this one. You see, this one is returning like a real object for which we can maybe print out something like this, square one. We can print out the shape, like the object itself, this way, and you have like an object. When we talk about object, you guys know what an object is. But that's not with the case with the shape, because it's implemented as a contract, and once you satisfy it, it tells you like, oh, you are part of me, but it's not a real object. So we can comment this out, maybe run this for the sake of the doubting Thomases in among us. Let's just run this. Okay, so then you can see that this is the objects. Like the first one is the square, and the second is the circle. Apologies for the dog barking, but yeah. So the magic that comes with interfaces is that you can create an object out of, not an object, but assign an object of the type shape, an interface, and these ones can sort of implement them one way or the other. So let's see. So here, what you can do is you can now assign shape, which is of type shape, to, let's say, square one, or let's say circle one. Right. So you see, I've been able to assign it without any like problem or whatsoever. Okay. So yeah. So then in this case, let me just try again with square one as well. But with a typical typed language, like a statically typed language, this is not common. I don't know if any of you guys know what I'm saying. Like you can't define um, um, you can't define a shape and now later on you come and use a square like to assign to it. The compiler will just say no, this is not what it is, right? But what the interface is doing is that it's accommodating it, because then this circle one here is of type circle and square is of type square, and they all satisfy these two methods. They have these two methods here down here. They have these two methods. They all satisfy the interface, the contracts that the interface implements. So this is the contract. The contract is saying that shape interface is saying that for you to implement me, you have to have an area method and return this particular type float64, and have you also have to have a perimeter method and return the same type. If you have a perimeter method and you return a type string or a type, let's say map or any other type, it will not work. You can't satisfy the contract. You must satisfy everything. So basically this is what an interface is. So it gives you the opportunity to sort of decouple types, but at the same time unite them one way or the other, because then unlike Java or like any other like type language that exists, you don't have to say, oh, something extends a certain interface or implements something. No, it's tied to that particular type, but it's decoupled. You just have to satisfy the contracts by implementing those methods, and that's all. You can behave as though you are like that particular type, which is a shape. I hope it makes sense one way or the other. The reason you are seeing this is because we are not printing the shape or like using the shape one way or the other. But once you print it, you should see that line going away. Yeah. So this is basically what an interface is. An interface is not a concrete type. It's an abstract type. It's a type that it's not an actual type, because then you can't create a new object out of it. You can't instantiate or initialize a new object out of it. It's just a contract, and once any other concrete type satisfies that contract, then it can behave as though it's part of it. So here you can say shape.area. Yes, and it will work, because what's happening here is that now shape is actually a square. So it will implement the area method on the square and give you whatever answer you want. And in this case, it might give you something. Let's run it and see. Sorry, should give you something. Yeah, like 100, which is like L times L, 10 times 10, 100. Yeah. Okay, so we'll continue with. I at least I hope that like you guys understand what like an interface is. So it's basically a contract, an abstract type that does not it's not a concrete type. It does not instantiate or initialize new objects. No, other concrete types have to satisfy the contracts, which are mostly methods, and yeah, you can use it anywhere you want. Yeah. So if you are a backend guy and you do a lot of test or database operation, one useful case would be for you to, maybe for example, you have like 2 or 3 relational database and 1 document database, right? You can implement Postgres in a way where the Postgres driver and the DSN and all of that is a type. Now MongoDB and its DSN and all of that is also a type. Neon, whatever database you are using, they all like are types. Then you implement the same what's the name methods on them. So then you can just call a DB like as an interface, like DB interface, and that's all. You just be using that DB around instead of handling, let's say handling them one by one, like what's the name, like Postgres, MongoDB, and what have you, like SQLite, whatever, like yeah. So that's one useful case. It helps you to decouple like implementation, but still uniting them one or the other, because then you have to satisfy the contract. Okay, my time is running out. I have to move on. So guys from TypeScript, you know this. Any means open, generic, like I'm open to all objects, and this is one way which Go allows us to implement generics or like make our programs a bit dynamic. So instead of maybe assigning a certain type to your let's say your objects, let's create a variable and call it age. You can just create an empty interface like this, and it's ready to accept anything in the world. It should accept a string, integer, float, and what have you, like, because this here is equal to the any interface. Again, the alias for it is an any. You can just use any this way and it will work. But beneath the any, or what is beneath the any, underlying the any, is an empty interface. What it means is that for this empty interface, anytime you define an empty interface, all objects actually implement zero methods, or on a certain they satisfy the contract. Let me show you here. So you can do something like this. You can implement a type like empty, let's call it empty interface or empty shape this way, and call this empty interface this way. Now we don't implement any contracts beneath, so all types would satisfy this because it's zero, and all types have zero methods one way or the other. Not necessarily zero methods, but like they have their own methods, but they still have zero methods, and they implement this. So yeah, strings, floats, integers, and all of that will satisfy with this. So you can just say, and this is an empty interface, empty shape, and it will work. Yeah, you can assign age to 1.0 or 1.9. You can assign age to a string, then print it out, and Go compiler will not scream or anything. Like even the linter will keep quiet for you because it's an empty interface. Cool. Let's move on to the next thing. Time is running out. Okay, so type assertion. This is very important because for this I'll just use this particular example here. So in a case where you are passing any of these, like let's say a square or a circle, right? You want to determine the area of it, but maybe somewhere in line 13 you forgot that you assigned it to an interface, right? Or even if you didn't forget and you are deliberate about it, what you can do is you actually have to type you actually have to check the type before you perform any operation on it, because an interface is an open contract. Several different other types, once they implement the method, they can satisfy it. So here this could be a circle coming in as a parameter or an argument, depending on the language you are coming from. You can say function print area, then you pass in, let's say, circle. So here you have a circle value coming in. Now what you do here is you pick the parameter value, then you check the type and see, oh, is this a circle? So here you say s.circle, like you type s.circle, the name of the type. If it is true, then do this. If it is false, then maybe this is not what I was looking for, do something else. Then you can have the condition coming. If not, this is too open, you don't know what to expect, and we are all acquainted to the fact that dynamicity is good, but being too much open too can hurt, because then you just open yourself up to so much errors like that. You don't want to, unnecessary errors. Yeah, so this is basically type assertion. It works, and you are just checking what type, because it's an open type, it's generic, it's dynamic, you don't know what's coming, you're just checking what type it is before you perform any action or value on top of it. Yeah, so that's type assertions for you. And there are built-in interfaces in Go. When you are learning Go, you see stuff like this, especially with the reader. When you are reading files from CSV and what's not, you see something like this, IO. Let's go to the IO package and look for the reader. So the same method, it's a type, but it's an interface. Anytime you see ER ending with a particular like type, it's likely an interface. That's like Go's way of saying that, hey, that's how we create an interface. So when you look into the documentation, you say type reader is an interface, and it implements this method read. So the read accepts bytes and returns number of integer and error. So any other type that implements this actually can satisfy the reader interface and it will work. Yeah, so this is one built-in interface that you might come across, basically for input and output stuff like reading and writing to files, that sort of thing. IO works. And then we have the stringer interface. I think Dennis used it last week and it was so cool, like, oops, I think this is the name, fmt.stringer. So it implements a string interface, and what the string interface does is that when you go to the stringer, it's any type that has a string interface, a string method on it, actually can implement this interface. So we can come here to our square type. This is our square type. Yeah, this is our square type. Then actually come here and say s blah blah blah, implement the value and pointer receiver string. Then this is the type. I hope we are right. It brings us this. Then let's just return something. Say this is a square, something like this, and it would the what's the name? It implements this interface, the stringer interface. So wherever you see a stringer type used, you can use this thing and it will work. The square. What else? And there's one last one, and the error one. I think last 2 weeks I handled error. Error also is an interface that implements error. You can check it out for yourself if you have Go. So, and beneath it is a string. Basically, errors in Go are strings. Like it will just pop out a string for you. That's all, and you handle it based on what you want to do. So this is built-in interfaces. Sorry for rushing through, but like I want to still stay within the time frame because you guys have stuff to do. Anyway, so the last thing I want to talk about is interface embedding. Now, with interface embedding, what you are looking at is, let's say you have several other interfaces. Like let's say, let me take this thing off. For now, we've created only one interface called a shape. We can create another interface called let's say quadrilateral with just four-sided figures. Interface, yes, something like this. Good. Then we can create another interface again. Okay, so let's say these ones where quadrilateral is, let's say is the condition or the contract is only area. So let's copy this and put this one here. Good. Now we can come here again and create one more interface and call it, let's say, polygon. Right, just saying, then create an interface out of it, control out of it, and then we embed, instead of writing, let's say, area and perimeter or all the methods that satisfy quad and shape, we can just bring quad and shape, this way, and it will sort of unpack the methods that like implements them beneath. So imagine quad had another method that is called is four-sided, which returns, let's say, a boolean or something. Another method called is four-sided that implements a boolean. Then here you'd unpack itself, and you have area is four-sided, a perimeter. Then that will form the polygon interface. So this is basically interface embedding. And now you can just go about using interface. So here you can just change it to polygon, and you should be able to have it working. If it doesn't work, then it's because these ones here don't implement what is four-sided, right? They don't implement it four-sided, so you don't expect it to work, right? So we'll just change it back to shape. And one last thing, I'll bring my presentation to a close. So obviously you might not fully understand whatever is going on here, but this is like to where your appetite is, let you know what's possible with interfaces. In fact, with real world application, as I said, like if you're doing a server-side development or anything, you can use this as a way to group certain related objects and use them one or the other. and it makes your code very clean, very nice. You just pass the interface around and it works. Now, last thing, Dennis did presented last week about like value receivers and type receivers. Again, in this case, if this might be a bit confusing, but I hope you guys get it. If you still don't get it, maybe you can catch me one-on-one on the Discord server, and I'll just log on with you and we'll talk about it. But if not, you can read more about it yourself. So what I'm trying to say is that um, the value receiver here, right? This one here is a pointer receiver because it's pointing to the main type. So any change that you do here, let's say you assign the length to a new value here, it's actually affecting the field here, like one way or the other. But if you take this off, it becomes value. If you take the star off, now it's a copy of this, and this is like on its own. So if you change the length here, it doesn't affect the main thing one way or the other. Now, if your interface is made up of methods that are value receivers, then the value that the objects that you assign, in this case circle one that you assign to the interface, should also be a value receiver. It should not be a pointer. It should be a value receiver. If not, you might find yourself wanting one way or the other. But if it's a pointer receiver, it's not work. Again, in the same case, if here, which is a pointer receiver, if your type is implementing a pointer receiver, then it should implement a pointer receiver. The reason why you are seeing this work is because new square is a constructor, and new square returns a pointer. So if you see new square, let's go to new square. New square returns a pointer to square. So this is where it returns. This is it, the address, the memory address of square. And of course, it's implementing a square interface. A square pointer receiver. So my interface is quiet, and it's like the contract is silent about it because the object I'm assigning to it is receiving a receiver interface. Again, this might sound a bit like messy, but assuming that like I changed this here to a receiver, a value receiver, and I didn't change it to I didn't implement this as a pointer, then I can assign square to it. I can assign square to the same shape. You see here, it's saying that no, like the type that's not implement shape as area method has a pointer receiver. So therefore, in such a case, then I have to come here and take this off, then implement square like this. Like this is a value type, let me put it that way, and passing, let's say 10 directly. And once I pass in 10 directly, I have to also come to the methods and change these ones like this. I really hope this thing works. Yeah, it will work, of course. And change this one like this, and it will stop complaining, because now value for value, receiver for receiver. The object is a receiver type, it's not a pointer, and the interface actually satisfies values as well, not pointers. If you mix them, you have an error. Yeah. So 7:43, I think 30 minutes already gone. This is where I would like to bring the end of my presentation. Again, I know things where I am moving a bit fast, but that's the aim of this presentation, to wear your appetite so that you can go deep into it. And if you have any challenge whilst you're studying or something, the server is there for us to discuss. And I think we have much fun. So this is the end of my presentation. If you have any question, I'm open to answer them. Thank you very much for your attention and audience.